time for the song, so we'll do the song later. The next speaker actually could give us a song, if I remember rightly, is a colleague of Gustavo's and Rosa's at Nuclear, and someone that I've worked with for many years as well. This is Alvaro Folhas in Nuclear in Portugal, and he's going to tell us about the way of using telescopes in real time and some of the background to what you have to do. It's all yours, Alvaro. You may want to turn your mic on.
Thank you, Fraser, for this introduction. I'm a Portuguese physics and chemistry teacher and proudly a member of the Nuclear Corps. I'm doing my PhD about astronomy as a lever for science education at University of Coimbra. I want to thank this opportunity to talk a little bit about interdisciplinarity from an astronomical observation made using Faulkes telescope north by remote access in real time. I think I'm gonna share my screen to present it. Could be. Okay, I suppose. I think.
Yeah, that's perfect. We see that.
Okay, thank you. We have already in this conference a chance to understand the huge importance of using remote telescopes in schools, as Fraser, Lewis, Andy Newsam, and Sarah Roberts has shown so clearly before me. A few words about astronomy implications in different ways in our lives. For centuries, astronomy was a core subject in classical education. Astronomy has a huge influence on human history and culture. Understand the regularity of the position of stars in the sky could be the reason why our ancestors settled in a place and starting producing food and everything else they needed. Some academics suppose astronomy was the first science and the starting point to mathematics and physics. For example, the meaning of the word heaven, for instance, suggests an ancient link between astronomy and religion, and the big philosophical questions about ourselves and our place in the universe are part of this. Observing the sky allows the construction of the calendar, the knowledge of succession of night and day, the seasons of the year, the moon phase, the sea tides, etc., etc., etc. Also, the origin of matter from that of stars to the constitution of our own body and everything that surrounds us are written in the sky. Astronomy harnesses curiosity and imagination, and we need this at school. So, astronomy rekindles students' interest in science and technology. We may use astronomy to teach different concepts of several different subjects, one by one, or it can be used with an integrative approach with cross-curricular connection. It's a free resource and provide material to do inquiry-based learning activities and projects, to join different concepts in the global task, creating consistent and meaningful knowledge. And we may add to this the awareness to a sustainable world also. But let's talk about this approach from the astronomical observation using Faulkes telescoping north. This telescope is settled on the top of Haleakala here in Hawaii, and believe it or not, the shortest distance between my home and this observatory, a little bit more than 12,000 kilometers. That's a curve we pass here in Alaska. Students must investigate, why is that? What are the implications for navigation now and in the past, for example? As we may see, Hawaii, here, where is my mouse? Is over there, as minor 10 hours than UTC. So during our morning and afternoon at Europe, it's still night at Hawaii, and we may observe at in school on regular class. Knowing that, we may ask, for instance, what is the orientation of Earth rotation? Appealing for thinking and not memorizing this kind of information. As I said before, the Faulkes telescope north is on the top of Haleakala Mountain, 3,000 meters high, but we must ask why they put the observatory so high. That's a question to discuss about moisture in atmosphere, light pollution, clouds, the patrimony of the sky we may share with each other, and lots of things. Talking a little bit about this telescope, Faulkes telescope north is a reflecting telescope with 2 meters primary mirror to reflect the wall captured light to a second mirror, as we see in this scheme. And from this mirror to the CCD put in the focus of the telescope. We may talk about this, about physics laws of optics, discuss about the proportion of number of photons acquired if we use a smaller diameter telescope, and even the exposition time needed to impress a CCD using just mathematics. Or we may discuss about the behavior of light if we use a refracting telescope, for instance, faced to the different speed inside the lens of the different wavelength. That's just some suggestions we can discuss using a telescope. But we may talk also about human vision and use it to discuss the lens here, the lens behavior to focus the image on eye retina, the structure of color vision for cone cells, this kind of cells you can see here, present on fovea. Fovea is this region of the retina, as you can see. This is the part, is the direct vision. If we saw directly, we can perceive better the colors. But if we saw the sky in the night, we may use the peripheral vision, because there's more reach in other kind of structures, the rod cells, who are more sensitive to the light. We may transfer also these concepts to CCD sensors and discuss the semiconductors, how they work, and how they can be used, this technology in our lives in different fields, for example. We may use this event also to talk about chemistry, about photons and the emission of electronic transitions in hydrogen atoms, especially, for example, using H-alpha filter to show just photons results from the decay of the third, it's here, the third level to the second level of energy in this atom. We may use it to several different calculations about chemistry also, but the most important for me is provide something visual to students about these concepts to make them meaningful. They can see this image, for instance, is represent just this transition of the hydrogen presented in this nebula. They may see what happens when this transition occurs. For the session I made in June with the help of Gustavo, using this telescope, it must be prepared in advance, and for this I use Stellarium and set this location of Hawaii, time and date for the observation, and this is for saving time of the telescope. I define the alignment of the celestial objects and ordering them in the proper way to avoid drifting the telescope around the sky. This is a way to use. We have just a slot, and we have to use it in the better way possible to achieve the most objects possibly we can see in the night. To illustrate this procedure, I'm gonna show you a small video made in this session. Here we're gonna start to appoint the telescope to M27, the Dumbbell Nebula. We ask for the filter, is the red filter. The telescope is now pointing the object, as you may see. This is Gustavo talking to me. As you may see now, the telescope is pointing now for the object we want, the object we choose in this list, in the target name. We may use also a manual way. Manual is putting the right ascension and declination of the object we intend to observe. Now he asks for 60 seconds. 60 seconds, that's because it's not so bright object in the sky. If we ask for a brighter object, we don't need so much time. We choose the time for specifically for some objects, and using this kind of telescope. Now it's after that the CCD send the image. Just one moment. This night it was very bright because it's just full moon, and full moon is it's not the better nights to observe. Now you're gonna see it's the red filter of the Dumbbell Nebula. After that, we are gonna choose the green channel, the green filter, and the position is the same because the object is the same. And we're gonna acquire just the green photons to the sensors, to the CCD, and I suppose it's enough. And after that, we have here the section. We have the three images, the three colors, the red, the green, and the blue. On the FITS format, it's a kind of format you use it for astronomical purposes. And we're gonna mix this image of this lovely nebula As we may see, the shape and the information produced on each filter, it's quite different. And we may recall the structures of human color vision, as we talked a few minutes ago, on the cone cells. Or we can talk about some principles of physics, about electromagnetic radiation and waves and everything. So, mixed the images, we have this beautiful and colorful planetary nebula, ashes from that star, expanding plasma and ionized gases through space, and all the metals and other elements produced on this process. I use remote telescopes several times with my students, sometimes at classroom. Other times, as you may see, all the students are very enthusiastic with this experience. Other times, we make some scholar projects as studying supernovas, making light curves over time, for instance, as we may see on these pictures. This is just a few ideas around the session of astronomical observation by remote telescopes and real time. I assure you that could be a significant experience for kids and a way to make them embrace science. I want to thank to Faulkes Telescope Project team, special to my friend Fraser Lewis, who helps every time I need it. Thanks also to everyone who spent their time to listen to this talk. The word is yours.
Thank you very much. No, you can't go. You have another 3 minutes yet. So I'll keep you talking for 3 minutes if I may, but thank you very much. And it's a pleasure working with you and the guys with Nucleo, as you know. You have a couple of comments on the chat window from Maria, who thought your photo was fantastic. I'm sure she wasn't alone in thinking that. And also Anna Costa saying hello as well. So yeah, that's fantastic. It's interesting that you're incorporating so much STEM. So we always think of astronomy as being quite isolated and it's a small part of physics, but you're talking about biology, you're talking about the eye, you're talking about the technology involved in the telescope and the CCDs and so on. So it's really good that you're doing that. Errol Simpson is asking about the software you were using. Do you hear me, Alvaro?
Yes,
okay.
All right.
He's asking, Errol's asking about the software you use to combine the images. What did you use?
I use SaucerJ usually. It's free. We can doing much more things than producing just beautiful images. We can measure objects. We can do lots of things with this software. And after that, I use Photoshop to equilibrate the colors to doing some better image from that, but it's not necessary. If we use SaucerJ is just fine. You can do the image like this one.
Good. I hesitate. It sounds like an advert, but there are instructions on how to use SaucerJ on the Faulkes Telescope website. I'll put the link in the chat in a few minutes' time. And interesting that your image is a pretty picture. You've chosen a dumbbell nebula. It's a very pretty object, but those colors kind of correspond to chemicals, right? So the red and the green start to tell us something about the elements that are in there. And there's a little white dwarf in the middle, and this is the explosion or the expansion of a star. So yeah, there's some nice science behind this image, not just the pretty picture. Alvaro, I think we have to move on. There's a quick question actually from Adriana, who's our next speaker as well, who is asking what age group is most suitable for these investigations.
Usually I made this investigation with high school students from 16 to 18 years old, usually. But we can do other things also with small students with 11 to 15 years also, especially for to produce this kind of image. I think it's a good starting point, because they love it, and that's a way they passionate for science, and just that it's very good. It's nice, because students are a runaway from science today, and we must stop this tenderness. We have to involve students producing something they enjoy, and that's the way we have to do.
Fantastic.
And Faulkes, it's a great help to this.
I absolutely quite agree with that one. Alvaro, we're going to have to leave it there, but thank you very much for your time and your
it's a pleasure.
talk today.
Thank you. Thank you to all.
We're going to move now to the next talk. It almost looks